Conservation of momentum. In an isolated system, with no external forces, acting, momentum is conserved and remains constant, so that the initial momentum is equal to the final momentum. When we have a collision, we have two or more objects, approach each other, and interact. Briefly. The momentum before collision is equal to the momentum after the collision. Remember that momentum is equal to the mass times the velocity. So the mass of the first object times the velocity of the first object I'll do it this way. This is before my collision. This is after my collision. I have my green object moving at its velocity, and I have my black object moving at its velocity. They impact. My green object now has a new velocity. My black object has a new velocity. Remember also that these are vectors. Here's an example. I have a 15,000 kilogram railroad car moving at, so that's my mass, and it's moving at 2.5 meters per second. That's my initial velocity. It's going to collide with a stationary car of mass 2. There's my two railroad cars that are colliding. They're on a railroad track, so their vectors are going to be on the same line. So my mass 1 times velocity 1 plus mass 2 times 0, or mass 2 times 0, is going to equal my mass and its new velocity plus this mass and its new velocity. All right. The black freight car is 0 to start with, so anything times 0 is 0. So I have 1,500 kilograms times 2.5 meters per second is equal to 1,500 kilograms times the new velocity plus 12,500 kilograms times the new velocity. Since one is hitting the other, they will move together. So the final velocity for both is the same. So I have 15,000 times 2.5 equals 15,000 plus 12,500 times the final velocity. If I divide these both by the same value, I'm going to have, no, I won't do that. 15,000 times 2.5 is equal to 37,500 is equal to 27,500 times the new velocity. If I divide both by 27,500, that gives me that my final velocity is equal to 1.4 meters per second, also going that direction to the right. We can have two kinds of collisions. We can have an elastic collision. We can have an inelastic. In an elastic collision, the objects bounce off each other. And they're usually bouncy or hard. Examples of that would be pool balls, air hockey, bowling ball, or a Newton's cradle. For an inelastic collision, the objects stick together and become one, act as one. And there's usually some kind of damage or deformation. And that would be dropping soft clay. That would be a bad car accident. That would be train cars that connect. In a chapter soon to come, we're going to be talking about energy. For the time being, understand that in an elastic collision, all the energy is contained in momentum. It's contained in the movement of the objects after the collision. In an inelastic collision, some of the energy goes into deforming or changing the objects that have been affected by the collision.